What is a complex number? Let's explore this fascinating mathematical concept together. Consider the equation x squared equals -1. Can any real number solve this? No real number satisfies this equation, since squaring always gives a positive result. So mathematicians defined a new number, I, as the square root of -1. This means I squared equals -1, the fundamental property of the imaginary unit. Now let's see how we build complex numbers using this imaginary unit. A complex number has a specific standard form that combines real and imaginary parts. Z equals A plus BI, where A and B are ordinary real numbers. The value A is called the real part of the complex number and BI is the imaginary part, with B being a real coefficient. Let's look at some concrete examples of complex numbers. 3 plus 2i has real part 3 and imaginary part 2. -1 plus 4i, the real part can be -2. 5 minus 3i, here the imaginary part is negative. Now let's visualize complex numbers geometrically on a plane. Welcome to the complex plane, also known as the Argand diagram. Here's our coordinate system where every point represents a complex number. The horizontal axis represents real values and the vertical axis represents imaginary values. Let's plot the complex number 3 plus 2i as a point on this plane. We label it z equals 3 plus 2i at coordinates 3, 2. An arrow from the origin to the point represents the complex number as a vector. Dashed lines show how the point projects onto each axis. The real component is 3 along the horizontal and 2i along the vertical. The modulus, or distance from the origin, equals the square root of 13. The angle theta measures the direction of the complex number from the positive real axis. Let's now explore an interesting pattern with the powers of I. The powers of I follow a repeating cycle every 4 steps. I to the 0 equals 1. Just like any number raised to 0, I to the first power is simply I itself. I squared equals -1, the defining property we started with. I cubed equals -I, and then the cycle repeats from here. I to the fourth returns to 1 and the pattern continues forever. Let's wrap up with a summary of everything we've learned. Here are the key ideas about complex numbers to remember. First, I is defined as the square root of -1. Every complex number has the form z equals a plus by, with real a and b. The modulus gives the distance from the origin using the Pythagorean theorem. Complex numbers beautifully extend the real number line into a two-dimensional plane, and that is the essence of complex numbers, a powerful extension of our number system.